I bet you didn't know that space might have a limit to how small it can get. It's a concept that has puzzled scientists and philosophers for centuries. The idea that there could be a smallest possible unit of space is both fascinating and mind-boggling. Imagine, for a moment, that the vast, seemingly infinite expanse of the universe could be broken down into tiny, indivisible pieces. This notion challenges our very understanding of the cosmos. Scientists have long wondered if space is infinitely divisible. Imagine slicing a cake. You can keep cutting it into smaller and smaller pieces, but you always end up with more pieces of cake. This analogy helps us grasp the concept of divisibility in a tangible way. But what if, at some point, you couldn't cut the cake any smaller? What if there was a fundamental limit to how small those pieces could get? No matter how many times you cut it, you still have pieces, right? This is how we typically think about space and matter. We assume that we can keep dividing and subdividing indefinitely. However, the reality might be far more complex and intriguing. What if, at a certain scale, the very fabric of space itself becomes indivisible? But what if space works differently? What if, instead of being infinitely divisible, space is made up of tiny, discrete units? This idea is not just science fiction. It's a serious scientific hypothesis. The concept of discrete space challenges our traditional notions and opens up a whole new realm of possibilities for understanding the universe. Quantum mechanics suggests that at the tiniest scales, space may come in discrete chunks. This theory is supported by the behavior of particles at the quantum level, where the rules of classical physics no longer apply. Instead, we enter a world governed by probabilities and uncertainties, where particles can exist in multiple states at once, and where the very nature of reality is fluid and dynamic. These are called Planck lengths, unimaginably small units where the laws of physics as we know them start to break down. The Planck length is about 1.6 by 10 to 35 meters, a scale so minuscule that it's almost impossible to comprehend. But how was this concept discovered? The Planck length was introduced by Max Planck in 1899. He was working on blackbody radiation and discovered that certain physical constants could be combined to form natural units of measurement. These units, now known as Planck units, include the Planck length, Planck time, and Planck mass. Planck's work laid the foundation for quantum theory, revolutionizing our understanding of the microscopic world. So, what does this mean for us? It means that our understanding of the universe is still evolving. The idea that space could be made up of tiny, indivisible units has profound implications for physics, cosmology, and our overall understanding of reality. It suggests that there is a fundamental limit to how much we can know about the universe, and that there are still many mysteries waiting to be uncovered. Well, it challenges our understanding of the universe's fabric. If space is indeed made up of discrete units, it could revolutionize our theories about the cosmos. It could help us develop new models of the universe that better explain its origins, structure, and behavior. This idea also has implications for the study of black holes, the Big Bang, and the nature of dark matter and dark energy. It might even bring us closer to a unified theory of everything, a theory that seamlessly integrates quantum mechanics and general relativity, providing a comprehensive framework for understanding the universe at all scales. Such a theory could unlock new technologies, new ways of thinking, and new possibilities for exploration and discovery. Next time you look up at the stars, remember, the vastness of space might just be built from tiny, indivisible bits. Mind-blowing, right? The universe is a vast and mysterious place, and the more we learn about it, the more we realize how much we still don't know. So keep wondering, keep exploring, and keep looking up at the stars. Who knows what incredible discoveries await us in the infinite expanse of space?